Welcome to IEEE 2013 project development. This project authorized by Star Technology. This paper title is Modeling and Testing of Cloud Application. This paper implemented by Java Core Technology. Next, we'll see the brief explanation about this paper. Our scope of this project is modeling and testing of cloud application. Here, testing and modeling here will be is the graph-based modeling and testing of cloud applications. In this paper, we formulate the computing cloud as a kind of graph. Here finally its present is set up algorithm to compose the cloud computation for using model-based graph. Here using a subgraph also implement to testing and modeling the cloud application. Scroll your paper. Give some algorithms clearly written in your some algorithms in this paper. Mainly this paper focuses on three parts. One is the reform of graph, another is the splitted graph, and finally is the merge graph. So properties of our cloud graph is a graph also contains a n number of vertices and edges. So here vertices are nodes. Nodes are the some network, some CPU or some system anything. So but edges is connected to the network manner. That's edges is a connecting between connection medium, that is directed connection or undirected connection for them one system to another system, like that here will be used. So every node, each and every node connected to the edges. So in our abstract clearly you get the information about edges and graph. Read your abstract clearly. So it also proposed model computation setup mods and subgraph of the judge, such that every edges contains a predicate evaluated the evaluation is true. So in this previous step you can clearly property access right as an attribute of a graph node. First our algorithm is dynamic cloud graph composition. So first is a reform cloud graph. So reform cloud graph, first look at your example. This is a cloud graph is a C1 and C dash is the reform of the graph. First, in your algorithm, cloud graph is contains vertices, edges, and period and resources. That means process and resources. So cloud graph is a computations next calculation for the shortest cloud computation for here using the hill coming cutting algorithm here using to find out the path. So find the shortest path computations. So it contains here n nodes. In our cloud graph contains here 5 nodes and edges are connected to the each nodes. First to find out the shortest node. For example, your reform first the dotted line, that means tossed lines denoted the smaller distance of the nodes. N here in your graph, N5, N2 and N3 are the shortest node. So this is our shortest path, and your C dash enabling interchange there because your our algorithm, that means skill climbing algorithm, minimum cutoff maximum flow. This is our the scope of the reform cloud graph. Here will be is first n look your graph, n5 to n3 is a minimum shortest path, but here it's not flow of maximum flow does not transfer to the data from maximum flow. So you can change the path from n5 to n2. N5 to n2 also minimum distance, but here n3 to n5 is a normal flow, not a maximum flow. So you can change the n5 to n2 is a maximum flow of minimum distance. This is our reform cloud graph construct them maximum flow minimum cut algorithms. This first algorithm is reform cloud graph. Next we can to the next we can see the next algorithm is a splitted graph. Splitted graph contains two graph. Each graph connected at least one edges. Connecting the at least one edges has been established to the each nodes. This is our cloud graph. That is a C is a cloud graph. It contains a number of nodes like that. So here using edge-gut algorithm to find out the find the solution for the splitted graph. Look here. First, you can give the input for the cloud graph. Cloud graph into splitted into some splitted into subgraphs. That is a C1, C2, C1. That is n connectivity. So first you can get the connectivity for the cloud graph, that is insert to some variables, and this variable into divided into using algorithm or edge cutting to you can get the subgraphs for the cloud graph. This is implement to split out the cloud graph for the next algorithm, and finally you can modeling and testing for the merge and reform algorithms. So merge algorithm you can split the graph, that is you can get the single graph for the cloud graph, that is same. Here you apply the splitter to get the subgraph for the n splitted into, you can get the more subgraphs. Finally merge algorithm splitted in splitted graphs, you can give the input, you can get them merge graph and reform again maximum flow of the graph. That is the final solution for our testing and modeling cloud. Mm, in our merge algorithm you can get the input, you give the input for the uh, load give the input for the C1 and C2, that is a two splitted graphs, that means a separate graph. Give the input for the two separate graph and mid to the single graph, that is the input and get the output. Here apply the collect the interaction between the C1 and C2. So here n number of iterations will be applied to the merging. If it is path is true, you can merged, else you can skip the next vertex to travel the edges. This is finally you can reform the maximum below, that is find out the shortest path and reform our merged graph. This is merged graph algorithm to testing and modeling for the cloud implementations. Finally our conclusion is we can implement to find out the optimized route and optimized way of network sharing through cloud. So implemented the graph phase level, that means graph theory model to implement the optimized interaction. Here we demonstrate and simulate the optimized graph routing algorithm, that means that means we apply the three algorithms. One is the reforming, another one is the splitting algorithm, and finally is the merging algorithm with reforming. In our reforming algorithm, we can apply the maximum flow and minimum cut algorithm to find out the optimized route traveling for the process and resource. Each process connected to the edges were resources to transmit the data from one node to another node. You can implement to the reform algorithm is first level. Next level algorithm is a split algorithm. You can get the large number of, that means n number of nodes in difficulty connected in a graph. You can apply to the split algorithm the give the input for the single graph, that means a complicated graph, and get the out from the subset of graph, that is split that graph C1 is a C1 graph is filtered to the two graphs, that is a C1 and C2, that is a split out algorithm. Next you can merge the algorithm to you can give the input for two subgraphs, you can finally get the merge graph, that is not a optimized graph. Again you can apply to the reform to get the optimized route and optimized output for the original solution of the testing and modeling cloud graph. So this is the purpose of our conclusion applied to the graph theoretical model to testing of the cloud applications. So maximum flow of the minimum cut. That is our conclusion of and scope of the project. Next we will see about how to run our project. And step by step. So first, create your own graph to implement our application to test our cloud application. Thank you for listening and thank you very much.